to do some improvements to it, but can't even access the code for it anymore. And so we're using now, going to try AI to develop methods that use AI as a coding resource, basically to fit a new breeding paradigm that we're going to propose that allows us to capture a lot more of that information that's even lost in some of these existing platforms. And so we could have a better representation of plant pedigrees. I work with hemp. It is an excellent candidate for this type of system because it's probably got, as with many other things that cannabis does well, it has lots of problems. And pedigrees is no exception to that. And the reason for that is we have lots of complex breeding efforts that have taken place. But we're lacking a lot of that breeding information because for decades this was done underground or in somebody's closet, basement, garage, places where they didn't really tell you what they were doing. And so we have a lot of information that's missing to visualize these. We have an example from Seed Finder, which is a website that actually tries to keep track of the parents of a lot of cannabis pedigrees. And it's going to be an example of what some of the key problems that we have, which if we could resolve, I think is what with hemp, we could provide a really robust tool. And so we've got the incomplete breeding schemes. You could see here that we have a Humboldt OG. It's an F5. That means there's 5 generations that have went through there. We have no information about of how it got to that point. We're missing parents. You can see there's an unknown strain for some of these. We also have predicted parents. So, the industry thinks they know what the parent is, but we really might not know what it is. And so this is kind of how that website actually tries to map things. And we could see that it's kind of confusing to look at because you don't know which is the male parent, you don't know which is the female parent. You've got some that have got 3 lines pointing to the same individual. If you look over at the Royal Highness over on the side. And so it creates, and this is probably, at least for the cannabis space, the best we got. And so there's really problems that we need to work on and refining. And so we're going to try to take some of those symbols used for animals and expand it, kind of make that more specific to plants, kind of create this robust system that we could feed in basically an Excel sheet, which is what a lot of plant breeders use to keep track of their pedigrees. And then they feed it into other software. So we're going to try to do the same thing. Instead of having distinct boxes for male and female individuals, we're going to use those same symbols to mark the lines to trace those that are going to those progeny. So that way, that same individual could be used as both a mother and a father in different crosses. And so we can retain that information without having the same individual represented 20 different times within that pedigree. We could also capture those distinct individuals. We could use dashed lines for really that unknown parents, something that we don't usually have in animal pedigrees, and as well as number of progeny, whether it's genetically diverse material or an inbred material, self-pollination, number of back crosses or selections. These are all things that are very plant specific that we lose all this information in existing pedigrees. And so we're trying to integrate this so we can actually follow it. And some of these were in kind of our version 1 prototype of this. And Dr. Dillon's really been the one pushing behind all that coding. I kind of gave him, this is what we need. This is how we need to structure it. And he's using the AI programs to code. And I've been looking at them to see if it's giving me what it should be giving me.